Enough, you'll remember the discovery of the hole in the ozone layer back in the 1980s. People in southern Australia were particularly concerned because lower levels of ozone meant higher UV and therefore more skin cancer. But these days, you don't hear much about the problem. Is it fixed? Well, Mark Horstman finds out and discovers a surprising connection between the ozone hole and global warming.
The year is 2065. Planet Earth is being cooked alive. Most of the ozone layer has been destroyed by chlorofluorocarbons. No longer are we shielded from ultraviolet radiation. Cancer rates skyrocket. Thankfully, this is a tale about how we chose a different future.
A good news story about how we've saved the world.
But for a long time, it seemed the end of the world was nigh. More than 15 kilometres high in the stratosphere, the ozone layer forms a natural sunscreen protecting life on Earth. But when rogue chlorine atoms from synthetic gases are let loose up there, they act as catalysts to pull apart the triple oxygen molecules of ozone.
Ozone depletion in the atmosphere is getting worse.
Since 1975, science knew that increasing the use of synthetic gases like chlorofluorocarbons, or even the exhaust of high-flying Concords, could degrade the ozone layer.
Those inert little molecules from spray cans or air conditioners may present a greater threat than a whole brace of nuclear missiles.
The world was alarmed, but there was little evidence to show the threat was real. Until 1985, that is, when a startling report was published in Nature. Meteorologist Jonathan Shanklin had been working in Antarctica to measure ozone levels above the Haley Research Station with this Dobson spectrophotometer.
I thought it would be helpful to show people this ozone data and compare it with 20 years earlier. And it would be the same. The only trouble was that in the springtime, it wasn't.
That may be the understatement of the century. John and his colleagues had discovered a gaping bite out of the ozone layer above Antarctica.
We were completely gobsmacked, as they say, when we saw this, because it wasn't expected. What we were able to show was that it was a systematic decrease by 30 to 40%, quite a dramatic change, and far outside anything that had been seen in the total record that we'd got.
During that same period, from the mid-70s to the mid-80s, Paul Fraser was recording a steady increase in levels of ozone-depleting gases.
And when the Shanklin paper was published, a whole new field of chemistry opened up because no one had considered that the special conditions in Antarctica would generate this extremely powerful mechanism for ozone destruction.
So what on earth was going on? During the winter, the Antarctic ozone layer gets cold enough that clouds actually form in the middle of the ozone layer, and it's chemical reactions on the surface of those clouds that allow in the spring very efficient reactions to take place that destroy the ozone.
There was a clear demonstration an industrial release chemical in minute amounts, relatively speaking, was having a massive effect on a major atmospheric constituent, and it was unprecedented.
Around the world, governments were galvanised into action.
By 1987, we had a Montreal Protocol. By 1990, CFCs were on the path to not being used anywhere. And by the late 90s, they were gone. And all we're left now is the residue of what we put into the atmosphere 30 years ago.
The air I'm breathing here comes straight off a vast ocean, direct from Antarctica. Now, there's just a handful of places in the world where the air is so clean that you can measure minute changes in the composition of the atmosphere. And this is one of them, the Cape Grim Monitoring Station in northwestern Tasmania.
If something's detected in the air here, that's strong evidence it's everywhere. Since the 1970s, it's become the most important station in the southern hemisphere. And for the ozone layer, the outlook is good.
Overall, there's been a significant net decline in what we call effective chlorine, and that's what drives ozone depletion. We are expecting to see an ozone recovery, but these CFCs are very persistent in the atmosphere. The atmosphere will remove them, but it takes hundreds of years. And so the long-term recovery of ozone is a slow process. We probably expect to see ozone recovery about 2060.
On the left is the world we're living with. On the right is the world where CFCs weren't banned. Low ozone concentrations are in blue, average in green.
If you let chlorofluorocarbons increase by 3% each year, starting in 1974, by the year 2065, virtually 2/3 of the ozone layer has been destroyed.
That's not just over the poles, but everywhere. The Antarctic ozone hole becomes a permanent year-round fixture with a twin over the North Pole. In the 2050s, something very scary happens in the modelled world. Ozone levels over the tropics collapse to near zero. Levels of UV radiation triple.
And UV radiation is used to sterilize things. If we'd never regulated CFCs, you wouldn't have been able to go outside for much time at all.
Occasionally I think about, well, what happened if things had gone wrong and we weren't able to carry the popular view, and people just said, oh, this is nonsense, and we want to keep our CFCs, for example. I don't know. It'd be certainly a serious health issue.
And here's the twist that links this story to the current debate about climate change. Ozone-depleting gases are extremely powerful greenhouse gases as well.
By limiting them through the Montreal Protocol, it's actually done more than the Kyoto Protocol did to limit the growth of greenhouse gases in the atmosphere.
I would say it's somewhere between 5 and 10% less greenhouse gas warming than there would have been because of the Montreal Protocol.
When doubts are raised about whether international agreements like the Kyoto Protocol can reduce industrial emissions in time to save us from the atmosphere, remember, it's been done before.
We went from the ozone layer being perfectly okay to 50% gone in the space of a decade. And that surely sends us a warning that we can change our planet very quickly without intending to do so.